Hey everyone, and welcome to another video in a series of videos in which we are talking about statistics. Today, this is a follow-up video on my video on interaction. So in that previous video, I talked about the theory and the meaning of interaction in epidemiological research. In this video, I want to show you in a practical sense how you can analyze interaction within SPSS in this case. I'm using exactly the same data that I used to provide the examples in that previous video, and you can download the dataset in the description of this video to mess around with yourself. So, of course, the first thing that we will need to do when we are analyzing anything really is visualize our data. Now, in this case, we have already seen those visualizations, but I do want to show you how you can get those visualizations in SPSS as well. So, of course, we are going to make a scatter plot, first of the relationship between CT value and vital capacity, and thereafter we're going to stratify it for smoking status. So let's begin by going to graphs, scatter/dot, simple scatter, define. We're going to place vital capacity on the y-axis as it's our dependent variable, and we're going to place CT value on the x-axis as it's our independent variable. We click paste to paste it in our syntax. We run the syntax, and then we will get our output. You might have noticed that my SPSS may have changed a little bit. That's because I've upgraded to the last version. So in my previous videos, I had 25 and now I have 29. But for the execution of the videos, there shouldn't be any very noticeable differences, but just so you know. So here we have the graph that looks very familiar to what we saw in the previous video. That one was just made with Excel. This one is made with SPSS. And just like in Excel, we can add a regression line to the one in SPSS as well by double clicking on the figure and then clicking on add fit line to total in the upper menu. And then we can close both dialogues after that, unless you want to make some other adjustments too. And there we see the familiar line. We also see that the regression equation, the corresponding equation, is pasted right on top. But of course, like I showed in the previous video, we want to now analyze this relationship separately for smokers and non-smokers in the visual sense. So we go back to graphs, scatter dot, we just follow the same steps, simple scatter, define. Instead of moving on now, we set our markers by smoking status. And we press paste, move to our syntaxes and run this newly pasted syntax. Once again, we will get the same graph, but it looks a bit different. We can see now that the dots are blue and red, blue indicating non-smokers and red indicating smokers. We can once again double click on this figure and then choose the option add fit line at subgroups to draw two regression lines for both groups. Once again, these are of course estimated with ordinary least squares, similar to how it was done in the previous video. And we can see that the regression equations for both groups have also been presented here. So of course, you typically will do this to also identify possible outliers in your data. In this case, we all kind of already knew what we were expecting. So let's move right ahead on to how to make a regression model in SPSS with an interaction term, because that was the way that we could investigate interaction. Now, before we run the regression, we actually have to make that interaction term. Because if we go to our data set, we only have case ID, which of course we don't use in our analyses. We have vital capacity, CT value, and smoking. But we also need our third variable, interaction, between smoking and CT value. And remember that the interaction term was nothing more than the multiplication of CT value and smoking status. So we can go ahead to transform compute variable to create a new variable. We will call the new variable interaction, and it is composed of the CT value multiplied by the smoking status. It's as simple as that. We paste and we go back to our syntax, run, and we go back to our data set to see what happened. And we have gotten a new variable, which is the product of the CT value and the smoking status. Now, let's go to Analyze, Linear Regression, under Regression, of course. And then in the dependent variable, we'll add vital capacity in liters And in the independent variables, we'll put CT value, smoking status, and interaction, of course. And then we will also add the confidence intervals around the estimates. Press paste, move to the syntax, run the syntax, and we will be presented with a bunch of output. Now, I'm not going to go over all of the output. As a matter of fact, I'll just look at the last table, the coefficients table. If you're not sure what the rest means, make sure you watch my first video on linear regression and SPSS, where I go over all of the tables that are presented. And here we can actually see a lot of familiar values. What we can see is the constant, which is 2.280. So that was the estimated value for vital capacity when all variables are equal to 0. In other words, when the CT value is 0 and when smoking is 0. In other words, it is the estimated vital capacity in liters for a non-smoker with a CT value of 0. Followed by that, we see the regression coefficient, which is 0.099. That is the estimated change in vital capacity for each unit in CT value that increases when all other variables are constant or 0. In other words, it's the change in vital capacity for non-smokers for each value of the CT value. So it's the regression slope for non-smokers, which we saw in the graph earlier. Then we see smoking status. So smoking status is the effect of smoking on vital capacity for each unit increase in smoking. There are only 2 units, smoking or non-smoking. So it is the estimated difference in vital capacity in liters for a smoker compared to a non-smoker when all other variables are 0. So for a CT value of 0. So it was the difference in intercept between non-smokers and smokers of the regression lines of viral load and vital capacity, which we also saw in the previous video. Finally, we see the interaction term, which equaled minus 0.106, which is the difference in effect of viral load on vital capacity for smokers compared to non-smokers. In other words, the slope of the regression line of smokers is 0.106 smaller than the slope of non-smokers. So it's just slightly in the negative. So the regression slope for non-smokers was 0.099, and the regression slope for smokers is 0.106 smaller than that regression slope of non-smokers. Now, finally, and we didn't see that in the previous video, but as I said, the reason that we are using interaction terms in these models is because we can statistically test that difference and determine whether there is a statistically significant difference in effect. And in this case, we can see that that is the case because the interaction term is strongly significant at the 0.05 alpha threshold. So that would leave us to decide whether we want to split our models into 2, which in this case we can do just to demonstrate what happens after that, or we can keep this model as is. But we do have to take into account that there is an interaction. So we either have to stratify the model using the interaction term, or we have to present 2 separate models, one for smokers and one for non-smokers on the other hand. So let's do exactly that last part. We can of course do that by splitting our data file with split file under data, split file, compare groups, and we want to compare smokers and non-smokers. So we add smoking to this dialog, paste, go to the syntax, run. Now we go back to regression, linear. Of course, we can take out smoking and the interaction because we are no longer need those because we are stratifying the model based on smoking. We paste and then we run that piece of script. And we see that we get everything stratified for smokers and non-smokers. And what we see is that just like we expected for non-smokers, the regression coefficients, the intercept is 2.280. We already saw that. The regression slope or the beta 1 coefficient is 0.099, which we have also seen already. But now we see the values for smoker. All right, so we see the intercept is 4.116, which is exactly as we expected because the intercept was on average 1.836 larger than the intercept of non-smokers. Well, 2.280 plus 1.836 is 4.116. So there you have that value. Subsequently, we see the regression slope of CT value for smokers, which was almost equal to 0 because we saw that the difference by the interaction term, when we added that to the regression coefficient for non-smokers, almost equals 0. Just a little bit below that because we saw that the regression slope was slightly negative, but almost 0. And that's exactly what we see here. The regression coefficient equals minus 0.007. In other words, the regression coefficient for non-smokers was 0.099 minus the interaction term, which was 0.106, and that equals minus 0.007. And there, the whole circle has been completed. So here you can see where all those values come from, and that the interaction term just shows you exactly that difference between those regression slope, but also allows you to statistically test whether that difference in association is significant or not. Now, there is one other way of statistically detecting whether an interaction is significant or not, and that is by model comparison or testing whether nested models improve the fit. Now, I'm quickly going to show you how to do that as a bonus because I think it's a better method than just simply adding the terms and testing them in isolation. So before we do that, we first have to disable our split file because we need to use the interaction term again. So we're going to split file. We're going to analyze all cases, and I'm just going to press OK for now so that we turn off the split file. Then we're going to go back to regression. We're going to linear, of course. And now we're going to add smoking status to block 1 next to CT value. But now we're also going to add interaction, not in the same block, but in the block after that. And I'll show you what this does in a second. Finally, we go to statistics and we choose R² change. Press continue, we press paste, we go back to the syntax, of course, we run, and then we'll take a look at what happens. So now we get the same output for 2 models in this case, but we also get an extra model summary table, which I'll get to in a second. Because first let's look at what those 2 models are. The first model is the model that we define in block 1, so including CT value and smoking status. The second model includes those variables as well, but in addition to that, also the interaction term. Now, the interest here is to kind of determine whether adding that interaction term to that baseline model improves the model significantly. And we can determine that by looking at the model summary table. We can look at the F change. So remember that linear regression testing the overall linear regression was done with the F test. And we can actually determine how much does the F change and does that statistically improve it. So in this case, we see that the second model, when comparing to the first model, has an F change, an estimated F change of 8.935, which with 1 and 56 degrees of freedom has a significant F change with an associated p-value of 0.04. So this is a very focused answer to the question, does interaction between CT value and smoking status significantly improve over a model that just includes CT value and smoking? Thus giving you a bit better answer than just testing the interaction coefficient, in my opinion. Now, it doesn't really change the conclusion because when you look at the significance of the interaction, it's exactly the same, 0.04. But still, I think that the model comparison method is slightly better than just testing the interaction in isolation. Well, that concludes the video. Hopefully you have learned something, and I'll see you in the next.